My name is Shikha Pathak. I'm the Manager Awareness and Skill Building at SciSec. Very warm welcome to today's webinar. This webinar is a part of SciSec's weekly series titled Samgacchadhwam. May we all progress together. The objective is to cover various cybersecurity topics and provide conceptual overviews. Let us first start with some ground rules. All attendees of this webinar will be on mute by default. Please ensure and double check that your mics are on mute so that we can have the session without any disruption. We will have a question and answer round at the end of this presentation. In case you have any questions, you can share them on the chat window and the speakers will respond after the presentation. We will be recording this webinar and the recording will be uploaded on SciSec's YouTube channel, so you can revisit it anytime later. This is the 29th webinar. The topic today is IoT security. We are sure that you will find this series of webinars very useful. Here's the list of all the upcoming webinars we have planned. We will soon be sharing the details of their dates and schedules with you on our social media handles and on our website. So please stay tuned. In case you want to access the videos of previous webinars, you can do that on SciSec's YouTube channel. We upload all the live recordings there. As usual, we will be having an assessment at the end of this webinar, which will be kept open for 60 minutes. The questions will be from topics which have already been covered in this webinar. Those who get 7 or more than 7 marks out of 10 will be provided with a certificate of achievement. Those who are unable to take the assessment will be provided with a certificate of participation. At the end of this assessment, you will also be asked to provide your feedback. Please provide your genuine feedback and be assured that it will have no bearing on your assessment. Please provide your details clearly while taking this assessment, as a certificate will be generated basis these details only. We will be sharing the link of the assessment in the question and answer chat session window. Please note that this assessment is open only for those who have participated in this webinar. Let me now take this opportunity to introduce the speakers for the day. We have with us Mr. Chinkal, who is a manager at Deloitte. He brings in several years of experience and practice at Deloitte India. His experience spans across IoT security, embedded device security, SCADA security, information security implementation, security risk assessment, privacy and compliance assessment, vulnerability and penetration testing, and implementing security solutions for endpoint. He is one of the key members who were involved in setting up the IoT security service for Deloitte India. We welcome you, Chinkal. We also have with us Neeraj, who is a manager with Deloitte and holds a master degree in computer science with over 8 years of extensive experience in penetration testing, wide range of embedded devices, products, and application. He is a certified ISA, cybersecurity fundamentalist specialist with vast hands-on experience in industrial cybersecurity, such as ICS plant, factory assessment, network architecture, and critical infrastructure, etc. We welcome both of you, and I'm sure that there'll be a lot to gain from this session, and there'll be a lot that you can share with your enriching experience. So welcome Chinkal and Neeraj. Now over to you, Neeraj, for the rest of the presentation.
Thank you. Thanks a lot, Shikha. Let me share my screen first so that we can start off. Let me know once you're able to see my screen.
Yes, it is visible. Yeah, Neeraj, you can go ahead.
Okay, thanks a lot. First of all, I would like to thank SciSec team for arranging this webinar. This is a very good opportunity to showcase and to connect with multiple professionals in different fields working together on cybersecurity, or people who are trying to build their career in cybersecurity, or maybe just some of the enthusiasts who are curious about knowing new things, or who are curious about how this IoT security is shaping up, or anything any new thing for that matter. And it's we are privileged to present this particular webinar on IoT security. This will be a fundamental webinar on IoT security, and we'll be talking mostly on the perspective of IoT security and why this is the need of the hour. We'll also be talking about some of the practical security implications of BLE. BLE is Bluetooth Low Energy. We'll be talking about it. However, first of all, as Shikha already given an introduction for me and Chinkle. However, just would like to tell you that we are both working in the space of cybersecurity with Deloitte India, and we have been part of multiple IoT initiatives, be it the at the global level in Deloitte, or be it for the ICS assessments, or for ICS or OT assessments, basically. So we have been a part of all those kind of assessments and engagements. So Chinkal will be starting off with the presentation. Chinkal, over to you.
Yeah, thank you, Neeraj. Thank you, Shikha, for inviting us to, have this webinar on IoT security. And thank you, SciSec K team. Okay, it's a pleasure and honor to make sure that we spread our awareness on certain areas that we practice on, so that more and more people can, be aware of what all the new things that are happening in this area. As Neeraj and Shikha mentioned, we have a lot of ground to cover in this quick webinar. We'll be talking about IoT security. What are certain recent attacks in last couple of years, that has happened in this area? What are the different protocols that are being used, among Internet of Things, that can be compromised easily by, either freelancers or attackers? What is OWASP IoT? And different kind of threats and attack vectors, and as well a quick hands-on demo. We had actually planned a demo, but considering the pandemic and all, it's difficult to execute demo in a webinar. But what my colleague Neeraj would go through you is a simple step-by-step approach of how you can compromise something as simple as Bluetooth, which is omnipresent in most of the people having Bluetooth based phones, or smart bands and all Bluetooth devices that is present every day with each and among of. So you can go ahead and practice. It's a simple step by step, and some of the recommendations that are there. Okay, Neeraj, you can move forward. So as many of you know, I would not, I would just go over quickly what Internet of Things is, because it's such a used term last couple of years. Each and every thing that is connected to internet, okay, whether it is not personal computers, but even your devices, cars, your home, your electronics, bulbs, small low power embedded devices, smart radios, your dog collar, and today some article I was reading, there are some smart embedded chips which can be embedded in human, so that they can come to office and have all their access. Somewhere in Europe they are experimenting all these things. So this is where Internet of Things developed, or the coin came. It was by a great guy called Kevin Aston, who coined it in way back in 1999. Okay, when he was giving a similar presentation. Why IoT security's need of the hour is because, as you can see from what we are presenting, we have a lot of industries and a lot of area where this is spectacularly been implemented and executed. If you say in like in 2008, we officially crossed the number of things which are interconnected to each other or to internet. Okay, that the devices or things or whatever, right, which are interconnected to each other, we have officially crossed the number of people present on earth. So you can imagine the kind of things that are now communicating to each other, right? And that happened way back in 2008. That's like almost 10-12 years back. And now we have a widespread usage of industry like telematics, where you have GPS, fuel diagnostics, where your air pressure, connected cars. You will see a lot of certain brands like Honda, AMG, and all major cars coming. Car manufacturers coming with this smart connected features, where and today's generation also needs that everything at their fingertips about their vehicle history and how much fuel it will have and what kind of diagnostics or servicing it is required and when. Then you have usage based insurance, where insurance companies are also taking feedback from certain things like your driver's behavior, and whether this was whether an accident had happened, or if there's a smoke alarm at your home, does it related to any damage claim that you are pursuing at an insurance. So even they are collecting data which you might not even be aware of through some of the smart devices. Then you have a lot of POS machines in retails. You'll see on petrol pumps or shopping malls or any kind of shops. You have a lot of POS machines, point of sale machines, where Amazon has also come up with certain shops called Amazon Go, where you can easily just scan any of the product, pick up from the aisle, scan it, and it gets deducted from your digital wallet as such, and you just walk out of the shop without paying anything, and the bill comes to your email, and then the payment goes out of digital wallet. So many of the Indian startups are also coming out with such ideas as well. Then you definitely have smart cities, which even the government is promoting it, where you have a lot of wastewater, where you have a lot of security, CCTVs, surveillance. Real estate companies are coming up with smart meters and all, where so that everything is connected, and data is easily available based on how much of electricity is consumed, where and how your waste disposal is happening, how different communications are happening in building sites like HVAC and AC and building management systems and all, right? You also have water purifiers and water controllers, how much water you are consuming. Now IoT is inbuilt in that as well, so you have big uh, gated communities and societies which are implementing this, so that individual water consumption in the end is also controlled, and there's less wastage of water, which is critical. You definitely have healthcare. Even end users can easily take up, like your Fitbits, smartwatch, Apple watches, which gives you ECG readings, sleep patterns, but also widespread in hospital industry, where you have a lot of CT scans, radiology has been connected real time, so that doctors can treat you over the internet, maybe if he's sitting at a different site altogether. So you also have smart pacemakers, where doctor can over Bluetooth or smart radio or Zigbee can take vitals of your heart, which is embedded, vitals of your pacemaker, which is embedded near your heart, to understand how is the performance and all, right? So you have all these things in healthcare also, and then smart grids, as I said, it's about smart meters and whether if there's a fault detection in your electric grids, which are being powered, nationally as well. So as you can see, more and more industries which are not only adopting it, but are also providing it as a end user service, or to consumers and to different industries. If they are not making products related to IoT, but they would be providing some service, or they would be an integrator, that would be integrating to different kind of industries. So this widespread increase of Internet of Things and the products related to that in our day-to-day industries, as well as our work and home use, has led to becoming ourselves aware of the security threats related to IoT. That is the reason we are going ahead with this topic, so that people, industries, whether it is government people, college students, researchers, they need to think on those lines as well, that it's no longer your traditional IT systems that are there. Everything is connected, and security needs to be thought of every time, right? So if you can quickly move out. So some of the recent cyber attacks that has happened using IoT in the last couple of years is something that we are trying to show here. We had the very famous St. Jude's Medical, which is a US-based healthcare company, where their cardiac devices, were hacked, and this was shown by security researchers. I think this was a couple of years back, 3 to 4 years back, if I'm not mistaken. Then you have the very shocking Mirai botnet. That's a very interesting case uh, where the hackers or they wrote a code where they deployed it on a lot of your home CCTV cameras, your smart thermostats, smart thermometers, which are connected to internet. Let's say your smart baby monitors also, right? And through them, they launched a DDoS attack to a DNS service provider called DIN, which used to provide DNS service to Facebook, Instagram, GitHub, and all. And that went down for 1.5 day. Just imagine the kind of business loss those companies had, not because they were attacked, but a DNS service provider was attacked, which was providing DNS to them. And by whom? Not your traditional computers or servers or VMs, but your simple devices, which maybe you were using at your home, but it was connected to internet, which you are not aware of. A lot of these devices like baby heart monitor and a lot of these devices which you are implemented at home, ideally they have a lot of default credentials which are not changed. Certain ports are open which you're not aware, and are continually accessing internet, which should be restricted. So some of the very basic features that could be avoided is not done, and that is what the attackers take advantage of. Right? You have a lot of Bluetooth devices and chips and a lot of health bands getting exploited. If you can even as recent as this year also, that you would have seen. Okay, can you move forward, Neeraj? So now we have seen uh, how it looks that what kind of attack vectors or what kind of impact this kind of devices have. Okay, but how the communication happens through this device in your traditional IT environment, right? You have data centers, you have your network devices like routers, switches, and you have your laptops and desktops which are connected to that, and even your servers where your applications are hosted. So you have traditional your LAN based communication, your traditional internet has through HTTP and HTTPS is secure. But when the area comes to Internet of Things, there are so many players, so many different devices. There are freelancers making devices. There are huge internet product companies making devices. There are so many different products being implemented at industrial side, manufacturing industrial side also called industrial IoT. That's another area, that's a very vast thing. And all these devices and products that are all communicating on different kind of protocols. They are not just communicating on HTTP or HTTPS. Even though we have HTTPS, we still see a lot of attacks or hacks being done. But then you a lot of protocols which are inherently not designed for security. So some of the most common IoT protocols are being used across in this area of products or ecosystem or industries is something that we would want to highlight. One of the things is Modbus, which is primarily a serial communication protocol used in PLCs or industrial devices, where you have manufacturing, conveyor belt, all those kind of supply chain, assembly line kind of factory floor. Then you also have LoRaWAN. LoRaWAN is nothing but it's a WAN kind of a device where it supports millions and millions of low power devices. So as small embedded chips designing for traffic lights management or parking sensors, which can be used in projects like smart cities or smart areas of any city, that can be communicated using LoRaWAN. Then you have MQTT, also known as Mosquito. So it works on a publish or a subscribe messaging model, where a device publishes and other devices are on the same channel, and then they subscribe to those messages. Again, it can be easily used or useful when you have remote locations, and the code is very small, so you don't require a lot of space to implement this kind of a protocol, nor it hogs the network bandwidth, which um, which different protocols or HTTPS would require. So it can be easily implemented where you have small devices, small communication between few couple of devices that needs to be done. And trust me, all of these are does not have encryption, or are not designed with security in mind. Then you have DNP3, which is again mostly used in process automation systems, and you would find mainly where you have electric grids, water treatment plants, or dams where PLCs and all been used. There you'll be used. A lot of companies which manufacture industrial IoT products or industrial automation process components use this particular protocol. And then you have Zigbee, which is a radio-based protocol, and it is used in your smart homes as well, between communicating between one of your hubs and smart products like smart bulbs or your smart devices at home. That is generally used for small scale small networks that you need to create, and it runs on your digital radios, that is right. So it is also used where your bandwidth is low power and low bandwidth is required, whether you want to implement at a very small scale, maybe in a room or maybe in a house or maybe in one big room, and not out at a widespread level, right? And then you have the ever present BLE, Bluetooth Low Energy. Now there's BLE 5.0 also released, which has been used on most of the new devices as well, and it is ideally used for short range communication, and it is very effective in communicating between two or more few devices that are there. So apart from this, these are the only list. There are a couple of more also, but what we have seen is that primarily you will see a mix of either this or some of these protocols being used. If you see any IoT implementation at your industries or at your home, or even your connected car and all, you will see RFID, maybe RFIDs or NFC, even those kind of is an example. But primarily you will see a mix of all these protocols that are used, that you need to be aware, so that you understand what are the security threats that they pose to the ecosystem, so that you can be well prepared for it. Okay, if you can move to next. Yeah, so we'll be talking about IoT OWASP standard. Okay, so this is nothing but it's a framework that was started by some developers and enterprises and manufacturers, that that came together to help the community, so that they improve all these things. So I think this was released in 2018, and they came help so that community can go back and use this this top 10 vulnerabilities that are there. They bucketed into this top 10, so that anyone in the world who is wants to improve their product, or who is researching or trying to find out different vulnerabilities, can easily identify and segregate in this different buckets of top 10 ideology. So it ranges from weak, guessable, hard-coded password I just mentioned. Many of the small firmware-related embedded devices, they don't bother to even change, and you can easily find out admin is the username password, or password, or whether it's a small router or hub. It would be like something XYZ 123. So it's very simple and guessable. You have a lot of insecure network services that are there, where they don't, when they are connected to internet, they don't verify the integrity or the authenticity, or any kind of remote control is there if any unauthorized person is trying to attack, right? Then you have a lot of insecure ecosystem interfaces. So you can basically identify if they are connecting to any backend or APIs or to cloud, or maybe even your mobile phone, like you have this health Fitbit or Apple Watch, or you have certain smart wearables where you connect to mobile app for syncing. So those are nothing but your ecosystem interfaces. So how they compromise the device or any of those components with respect to that, with if there's a lacking in the encryption, or if any authentication or authorization, are you connecting to the right device? Last year I tried connecting my device to different phone and it got connected. So that can be one of the very basic things you can check. A lot of this device lack secure update mechanism. If you're working in IT industry or IT security infosec area, you would know that how patching is of prime most importance, right? And there are weekly, monthly, quarterly schedules of patching your servers, your desktops and laptops. Now just imagine you want to patch, or you want to upgrade your CCTV cameras, or your smart AC or smart TV, or smart bands which you're wearing, or maybe your car which is connected to internet, whatever firmware is there. So how easy or difficult it is. And not only easy and difficult, your mobile releases, Google or Apple, they release versions of their firmware every couple of months. So, but they do it over there, but they have a checksum mechanism and a secure update mechanism. But it is very difficult to do it for such small embedded devices, and that's what the attackers take advantage of, right? And because of that, you inherently have any components which get outdated or are insecure to use it. Maybe because they were when they were released through supply chain, whether they were not they were not correctly hardened, or they were not at the optimum version level, and then or or the libraries or the components that are there are not secure enough. Also, with the rise of your smart wearables, you have these days smart shoes, your health wearables and all. A lot of your personal data, including your GPS location sharing, which again it's a privacy information, right, of yours, is being captured there, right? Your health stats, your heartbeats, your height, weight, something that is personal to you, right? Your age is all being captured on these devices, and not sufficient privacy measures or controls are being put into it, and that can be easily compromised by many of them. In Europe, we do have GDPR. In India, there's a personal data protection bill that is tabled in the parliament. So once that comes out, becomes a law, we would definitely have stricter privacy measures as such. And then you have insecure data storage and device management. So that talks about nothing but how the data is stored at those smart CCTVs or smart bands, or even your car data that is stored in your car, and how the device is managed. Let's say you want to throw away the device, still some part of your data would be there, right? You want to upgrade, you want to change it and move. So how those device management is being done, and what kind of monitoring is there in case if someone breaks into and is trying to manipulate those smart devices. So is there any alert or notification being sent to you or to the company? So all those things are not present, and that is what has been observed by this community, and that can be aggregated in this. In the end, you have certain things called physical hardening, which we have also seen. A lot of this device can be easily opened up. There is no physical tamper proofing. You just need a screw or something, and you can open up. You can see what the chips are. You can basically replicate the intellectual property. You can identify what controllers are being used, what are the ports that are open. If ports are open, you can connect it USB port, or you can just connect it. These days, you don't need a lot of technical skills to do that. You can just Google some of the things and you can easily connect, and you can download your own firmware and see how it is running. Or you can, try to extract those firmware and code from those devices to understand, what they have implemented and all, without proper secure erase, or like you take example of iPhones and iPads, how difficult it is to basically open through your own hands, right? You need to have a specialized tools and specialized people who have the required skill set to open those devices, because they have made it that way, right? But if you go and see some small products, toys, or smart products from something from China that comes on the local market, you have smart bulbs and all, it's very easy. You can just screw it open and you will get to know what kind of circuit has been present. So that is what the thought process has gone behind this, right? So if you can slightly go next.
Yes,
Yeah, so before we go, is there any question, or we can have at end of the session? I hope uh, you guys are understanding.
yeah,
If there
Chintan.
are any questions, requesting the participants to please share it in the chat window.
Okay, I think, Shika, if we can move ahead, maybe we can take a
Definitely, yeah.
separate, yeah,
Sure,
Q&A session. We can answer all the questions.
sure.
Yeah, thank you. So thanks, Chinkal, for giving a brief context to what IoT security is, why this is need of the hour, and why are we basically talking about the different connected devices, connected wearables, connected shoes, connected medical equipments. So there are multiple aspects that we are talking about. Chinkal has already spoken about many of them. However, apart from that, I would also, like to talk about the different attack vectors and threats that we see as far as any connected device or any IoT device, I would say for that matter. When we say any IoT device or any IoT product, that means it is somehow connected to, connected to either the internet, or there is some form of communication when it is wherein it is in a continuous sync with the either with the user, with the server, or somewhere there is a communication which is happening. So that is why we are saying this is a connected device, or it's a connected product, or IoT enabled basically. So coming to the attack vectors and threats, when we talk about any of the threats or any of the attack vectors, we talk about the complete IoT ecosystem. The complete IoT ecosystem would comprise of multiple, multiple components. So if I take an example of any one particular product, okay, I take an example of one, one NVR, which is a network video recorder. Okay, so one network video recorder might have multiple aspects of it. That might have a web console, wherein we are, trying to access the admin features of NVR, wherein we have multiple functionalities which the admin can access, recording the video, or storing the video in the cloud, or maybe processing it, or storing it. There are multiple features that an admin might have. Okay, so that is a web console we are talking about. Okay, then the other aspect of it could be a mobile application. So for any network video recorder, the admin or the user might have the mobile application, wherein he or she can see that what video is being recorded, or what are the different footages that we have recorded, or how many of it can be stored. Those are some of the things that can be captured using the mobile application. So right now we spoke about two particular components. One is the web console, the other one is the mobile application. Both of these might have different kind of vulnerabilities in itself. Say, for example, the web application which is being configured, we need to log into the web application to see that what all videos are being captured by the NVR, or what all footages are being stored at what place. So in order to view that, the administrator needs to log in. Now to log in, he needs to use the username and password, which might be a default username or password, or which might be a weak password. So this web application becomes an attack surface for that particular ecosystem. Okay. And the threat we are talking about could be, anything which is a threat, could be anything which can be exploited, or somebody who is trying to, take the advantage out of it. So for mobile application, if we have some vulnerability, that again becomes an attack surface, and that can be exploited by any potential threat. Similarly, the NVR we are talking about, the NVR would have different kind of hardware components within it. The different kind of hardware components could be anything. It could be a USB interface that the NVR has. It could be a serial interface, or once we open the NVR physically, we have multiple components like the different kind of chipsets we have. Then we also have different kind of interfaces like the JTAG interface, UART interface. We also have SPI communication interface. Then we have flash memories. These are some of the hardware components that comes into place when we talk about different attack vectors for any IoT enabled product. Then the NVR, when we're talking about, we also have the cloud communication, wherein the footage or the the video recordings, those can be stored over the cloud. Okay, and usage of any insecure APIs, or sharing any video, or anything stored, anything stored or captured as part of the NVR to the cloud using any insecure communication like HTTP, which is a clear text protocol, would be something we can call as as an attack surface again, which can be exploited. Okay, then the network is something which is very widespread. So the NVR, which is located in certain network, it could be an internet, it could be an intranet, it could be a private network, it could be basically any network. So it depends that how that particular network is configured, how that particular network is that is segregated or not, how is it zoned basically. So on the basis of that, there are multiple attack surfaces or attack vectors that might be a possibility to be exploited. So as an overall, if you look at that, we spoke about the NVR, right? So the NVR has all these features, like it can be operated using the mobile, it can be operated using the web console by any admin. It has the feature which can connect to the cloud. It has different hardware components, and it is situated, or it is connected within a network wherein multiple network components are involved. So these all becomes the attack vectors and threats for any IoT ecosystem. Okay, so to understand what the IoT ecosystem is, or to understand what the IoT security is, we basically need to talk about multiple things. We need to also talk about we also need to talk about the different architectures of IoT enabled devices. We are talking about mostly on the the general aspect of IoT, that how any particular product can be exploited, or what could be the attack surface or vectors for the IoT product. However, we'll go ahead and we'll talk about one of the common protocol which is utilized, or which is leveraged for any of the IoT product we are talking about. So that is the BLE, which is Bluetooth Low Energy. So why we are taking this up is basically this is one of the most common protocols that we have seen as far as IoT security or IoT enabled products are concerned. So one of the recent publications we see from NIST that says that by 2021, uh, one third of all the connected products or any connected devices will be will have the BLE enabled feature. So the Bluetooth low energy devices will be 1/3 of total number of IoT devices, which in itself is a very huge number. Okay, and in order to understand that, we need to have basic concepts on what Bluetooth low energy is, how Bluetooth low energy works, and why are we calling it as a connected device or a connected product if BLE is implemented in any of the product. Okay. Now, before we move on, this particular section we actually wanted to have. We wanted to keep it for a demo. However, we could not do it because of the pandemic, and we have tried to showcase using the different screenshots. And we'll try to explain you that how you can, there's a very basic demo on attacking a smart bulb, wherein you can go ahead and sniff the communication of a smart bulb, and you can change the color, you can turn it on, you can turn it off. However, this is just a starting point for all those professionals or all those enthusiasts who want to kickstart in their IoT security career, or who wants to learn new technologies. Now, what we can talk about basically is what are the prerequisites to BLE when we are trying to exploit any smart bulb. Okay, the basic requirements for BLE exploitation is you need to have a laptop. You can have either a Linux box or a Windows box. However, I would recommend you have a Linux box because that will have more flexibilities, as you have the tools available very easily for that. Then you can have either an Bluetooth or a Bluetooth 4.0 dongle. Okay, these both the things can be utilized to perform the exploitation. However, if you go for an Bluetooth one, that will be very expensive in comparison to the Bluetooth 4.0 dongle. So these are the two hardware requirements that you need to have. Apart from that, the software requirements, most likely the if you have Kali installed within your environment, I think that would suffice itself. However, if you're utilizing Ubuntu, then you need to have Ubuntu utils as well. So you have multiple blogs available wherein you can go ahead and leverage those blogs to install the libraries or install the dependencies which are available with Ubuntu utils. We'll also be utilizing GAT tool and HCI tool, which are inbuilt with most of the Linux distributions. And we'll be also talking about how to perform the exploitation. But before we jump on the exploitation part of it, we'll go ahead and we'll talk about some of the basics of what is BLE, why are we talking about the BLE security, and what is it that can be exploited. Okay, and so one more thing to to all the participants, whatever we are talking about here, we are talking only from the perspective of knowledge sharing. We are only talking from the perspective of how we can start building secure devices, how we can start building secure connected products. So this is not from the you go ahead and unethically test someone else's device and you break it. This is not from that purpose, and it's only for an educational and knowledge sharing purpose. So please utilize it for that purpose itself. So we are talking about the Bluetooth low energy. So to give you a brief background of what Bluetooth low energy, Bluetooth low energy basically is used for the exchange of low level data, or wherein you do not have a huge amount of data to be exchanged in between two devices, and it operates on a very low energy or low powered battery. So if you install one battery for any of the device, for any Fitbit or for any thermostat, you can keep it running for a number of years also. And since it is always on and uses very less power or very less battery, this is now in use for most of the devices. And I'm talking about Bluetooth 4.0 right now. However, we have Bluetooth 5.0 also kickstarted already in the market. There are some significant differences that we have seen if we talk about from Bluetooth 4.0 to Bluetooth 5.0. So Bluetooth 5.0, if we talk about, there are multiple enhancements that have been done. So in Bluetooth 5.0, we have a data transmission speed up to 2 Mbps and communication the communication range has increased to 400 meters, which was less than 100 meters if we talk about Bluetooth 4.0. So in 5.0, the range has increased to somewhere around 400 meters. So those are some of the enhancements. The channels, the hopping channels are also different if we talk about Bluetooth 5.0. However, for this particular demo, we'll be talking about Bluetooth 4.0 only. The BLE Bluetooth Low Energy operates on 2.4 gigahertz. It's same as the Bluetooth, the classic Bluetooth, that is Bluetooth 2.0. And the low cost and the ease of implementation of this BLE is one of the features that has led to use this for most of the IoT devices which are there in the market. Okay, so to start off with the demo, what we are trying to do here, first of all, is we have taken a smart bulb. Okay, that smart bulb could be of any manufacturer that you think. Okay, it could be anything. In our case, it was one of the manufacturers that we took, and we tried to set it up in the lab to exploit it. And it is very it's a very basic example, and it's a very basic exploitation that we are trying to showcase. However, to set it up, you can turn on your Linux machine. As soon as you turn on your Linux machines, you need to connect your dongle, or you can set up your Ubuntu with your Ubuntu utils libraries. And then as soon as you set that up, you can use the HCI tool to configure your adapters, the Bluetooth adapters, which as soon as you configure that and it is up and ready, you can scan the Bluetooth low energy devices which are there in the vicinity. So you can fire this command called as HCI tool LE scan. That will give you all the possible or all the reachable Bluetooth BLE devices which are in range. Okay, so in our case, we had named the device called as Alta, and this device was already connected to one of the mobile applications that we were using. So there are multiple features that you can do with that mobile application for the bulb. You can turn it off, you can turn it on, you can change the colors, you can play music, you can change the background. So there are multiple things that you can do with that particular mobile application and using the bulb. Okay, now as soon as you hit HCI tool LE scan, which will scan all the discoverable or in-range devices for you, it will show up that if you have your device listed there, you can see that. So as soon as you see the name of your device, you would get to know that, yes, this is the particular device I'm looking for. And this is the MAC address for that particular Bluetooth. So this is also called as the Bluetooth address. Okay, this 34151375 1D8F is the Bluetooth address or the MAC address for the device that we scanned for. Then we'll go ahead and we'll try to connect with this. However, before we connect with the device, let me give you some introduction of how the connection happens. Okay, so the Bluetooth Classic and the BLE has a little bit a little bit of difference. So the architectural difference is also here. So in BLE, you have a master-slave communication and different modulation parameters as well. And the packet whitening is also in a different format when we talk about BLEs. And there are three layers basically when we talk about BLEs. We have a controller layer, we have a host layer, and we have an application layer. So the application layer is the one which sits on top of everything. Okay, and as soon as your applications are fired, I mean, those are all working on top of host and controller layer. The app layer will have the applications built on top, which will interact with the host layer, and then different APIs. So APIs will be part of the host layer, and then as soon as you interact with the API, the apps can perform whatever operations it has been intended to be. It has intended to perform. Then the controller layer, which is the lowest layer, that will have your radio controls, your connection linkings, your radio testing, and the interface to the host. So these are some of the, this is the BLE architecture basically that we are talking about. Okay, and this is how the connection happens. So the BLE connection basically happens using the AES 128 with CCM encryption engine. And there are various keys which are exchanged. So the first key, if I talk about which is exchanged, is called as the short-term key. And as soon as the advertisement comes to the to the user to connect to the device, it basically asks for a short-term key. As soon as you get the short-term key, that short-term key is used for the pairing. Once the short-term key is validated, then one more key is generated, which is called as long-term key. So long-term key is basically used for connections which can be utilized later on. There are two concepts basically here when we are talking about BLE connection. One is called as pairing, the other is called as BLE bonding. So BLE pairing happens over the short-term key or the key exchange. However, the bonding actually happens over the LTK, which is the long-term key. So again, there is one more security issue when we talk about BLE is how the LTKs or the long-term keys are stored within the device. So okay, moving on with the the connection, we are using the GAT tool here. The GAT tool can be utilized to connect to the Bluetooth device, which we identified or enumerated in the last section. So the Bluetooth address, if you see here, was identified as this 34151375, and we can use GAT tool to interactively connect with this particular Bluetooth address. So as soon as we hit GAT tool -I -B is the Bluetooth address, and we hit on connect, we can connect to that particular Bluetooth address. The problem here is this particular Bluetooth device, the bulb, is already connected to a mobile application, which is utilizing that bulb. However, we are still able to connect, and the bulb will be disconnected from the user who is using it. So we have already overtaken by connecting it. So the device actually would not know that somebody else has connected to it, and it will get disconnected. So this is anyways the first step to exploitation, and you are able to connect to the device. As soon as you are able to connect the device, there are different different kind of services which are running in the target device. Like you have the primary service, you have characteristics, you have different values, then you have descriptors. There are different parameters which you can look for as soon as you're connected to the Bluetooth device. Now, when you hit, there's a command called as primary. This is also one of the services which are running. As soon as you hit this primary command, you get to see the primary handles of the Bluetooth device, what it has. So in the next screenshot, you'll be able to see. So as soon as we hit the primary command, we are able to see the attribute handles here, okay, and the group handles also here. So the attribute handles are the individual handles where and the group handles are, there'll be multiple handles within one particular group handle. So as soon as you hit this primary, you get to know that which all are the attribute handles and which all are the group handles. This will actually help you to identify that what are those attribute handles which I can try to test further to understand that which handle is readable and which handle is writable. Now, when I say that which handle is readable and which handle is writable, that means that to glow the bulb or to shut the bulb, we should have some value or some descriptor or some handle which can either be read or which can either be written. So if we are able to read some particular handle, that means we are able to read the value which is currently being utilized by the bulb. And if we are able to write the value, that means we are able to change also the value which is set for that particular descriptor. So if, say, for example, the bulb is shut down right now and it's not on, if we want to turn it on, we have to identify that which particular handle is there, which we can write. And as soon as we are able to write that particular handle, the bulb will start glowing. So that is the exercise that we are trying to do here. As soon as we hit, we run the command characteristics, which is again another service command, which we can try to hit and try to understand the different individual handles here. So these are the different individual handles 0x002. These are all hex values which we can read using the characteristics command. Okay. Now using the char-desk command, what we can do is, if you see step 4, we can use this char-desk command to list all the handles in that particular attribute handle. So this 0x0001 is one of the attribute handles. If you see here in the primary one, we are using this attribute handle, and 0x00b is the group handle. So we are utilizing these particular attribute and the group handle to understand that what are the particular attribute handles in 0x00b. So if you see here, we have tried to do that, and as soon as we hit that command, we get all the handles which are listed there. Now, as soon as you identify the characteristic description of any particular handle or any particular attribute handle, basically, you have actually reached a point where you can start experimenting on these handles, whether it is a read handle, whether it is a write handle. We'll go ahead and we'll talk about how to read that or how to write that. However, before we go to that, there are certain common vulnerabilities or common Bluetooth weaknesses that we should also understand. So most of the cases, what happens is there are no user authentication present, and the Bluetooth specification, basically, if we talk about that, offers only the built-in device level authentication. The application and user level security that needs to be added by the application developer. So in most of the cases where you're simply able to communicate with the BLE device using your Kali system, or you're simply able to connect to it, that means it is not using any user authentication. And actually, the BLE, the motto of BLE is that it just works. So if it just works, that means there is no user authentication. There are 3 levels of security which are implemented when we talk about BLE. One is no user authentication. The other one is there is some level of encryption. When the key exchange has happened, then the channel is encrypted, and then there is the highest level of encryption, which in my experience I have not seen in any of the devices as of now, which is called as out of band, wherein the key exchange happens using some other communication method, be, something like you can say NFC. And then once the key exchange has happened, then the whole communication channel for the BLE is encrypted, and then the communication begins for the BLE. So these are some of the, uh, I can say, security weaknesses that Bluetooth already has. Okay. Now here we have already identified the attribute handles. We'll now try to, read those handles, and we'll try to write as well those handles to understand which is the read handle and which is the write handle. So to read any handle, we have this command called as char-read hyphen handle, and then the handle value. If you see here, we have tried to read the characteristic of this particular handle 0x0029. And as soon as we hit this command, we get the value, the descriptor value here. That is again a hex value. And we get to know that, yes, this particular handle is a read handle. And we are able to read the value, that what is the value which is being utilized by this particular handle. Now there is some trial and error also which we have to do. If this is a very simple and a very straightforward method that we are talking about. Okay. Now, if you want to read any particular handle, or if you want to write any particular handle, what we need to do is we need to run this particular command char read handle, and then the handle value, each handle one by one, because you'll not have too many handles. If you go through it, you might have some 25, 30 handles for that matter, for most of the BLE devices. And as soon as you hit on that, you get to know that whether it is a read or it is a write. Say, for example, we have tried to write a handle whose attribute handle value is 0000B. As soon as we hit char write request for this particular handle and the value, that we want to write, we see that the request fails. Why this particular request is failed is because this particular attribute is not writable. So it's a read handle only. So the handle which is only for reading, you cannot write it. And as soon as you try to write, it will give you the message that this particular attribute cannot be written. And you get to know that yes, this particular handle is not a right handle. So if you try those attribute handles one by one, you get to know that which is a read handle and which is a right handle. Once you have identified that which is a read handle and which is a right handle, you can list down the right handles, and then you can start experimenting with different hex values. So you can get there are a number of online places where you can go and you can for bulbs you can have the hex values, that what could be the hex value for this particular color, for red, for green, and you can try to put those values here. So if you see in the last screenshot, we have written char write request for this particular handle 0x002b, and we have given the hex value called as FFFFFF. Now, as soon as this particular value is given, our bulb has turned on. So that is the correct right handle that we have identified. And as soon as we give that, the handle value or the descriptor value has been modified, and now the new value is the one which we have tried to set. Similarly, you can give any other value and you can change the color, or you can do any other, you can do any other thing for that matter. So this is a very basic example of what we tried to show you via Bluetooth. However, there are different, there are different kind of attacks, which is man in the middle. You have you have a tool called as BTLE Juice, which you can you can go ahead and you can read about it, which will help you in attacking the, basically you can replay the messages, or basically you can replay any of the communication on the go if you use BTLA use. This Ubuntu device, what we have talked about, is a very powerful device, which again can be used for sniffing the Bluetooth communication. However, this is again also a passive device, which you can utilize for sniffing the any of the Bluetooth. The range for Ubuntu would be very good, so you can utilize that. However, there are multiple, aspects of IoT security which we can talk about. Though we chose BLE to go on with because this is one of the simplest and the widely available protocol or widely available feature that most of the devices might have. And you can, if you want to do research, or if you want to, go ahead and try to do more sophisticated attacks with any of the products that you might have or you might want to have, you can start doing that. There are some of the recommendations that we have tried to mention here. Like organizations should have a policy when they are when they are implementing, when they are deploying any of the Bluetooth enabled products. So they should have a policy on what to use as an encryption and how to use the pairing mechanisms. Okay, these should be clearly documented, and the developers who are trying to develop it, they should be thoroughly they should be thoroughly aware of how the Bluetooth pairing or how the Bluetooth encryption should be enabled, or how it should be deployed. The secure pairing and the authentication mechanism should be adequately implemented. Then the storage, which Chinkal was also talking about, the data storage or the privacy concerns. These are also some of the key features that one should think of while they are making any of the IoT enabled product or the BLE enabled product. And configuring the encryption size of any of the encryption mechanism that we are choosing is one of the most important thing, or that is of paramount importance, I would say. And the last recommendation that we are trying to talk about is the device must prompt the user to authorize all the incoming Bluetooth connection requests. So in this case, what we have seen is the user was already connected to one of the mobile application. However, from our Kali machine, we were able to overshadow that, and then we were able to access it. And the user who was already connected, they got disconnected out of it. So that should not happen. any user authentication which is happening, they must prompt the user to authorize all incoming connection, and it should not be always in discoverable mode. So only on the need base or only when it is required, it should have some limit or some interval when it becomes discoverable, or it should have some access mechanism implemented that on these particular requests the device will become discoverable. So these are some of the recommendations that we wanted to talk about. And some of the the assessment toolkit, if you since we are talking about the basic IoT security, we wanted to showcase that what are some of the toolkits that you can utilize to kickstart with any of the hardware testing or any IoT security testing. So you can utilize either the JTAG, you can use a simple Raspberry Pi, Arduino. You can also utilize the Shikra or the other devices. Shikra is one of the devices wherein you can utilize it for the UART, JTAG, everything actually. So that is one of the most flexible device that we can have. And then some of the basic software requirements that you can have for IoT assessments are the software like GNU Radio, GQRX. These are some of the radio tools that you can have. And there are other tools also. You can have there are a number of tools basically available in one of the Linux distribution called as Black Arc. You can utilize that. That is one of the most amazing Linux distributions I have come across. So you can utilize that to perform multiple researches or whatever sort of assessment that you want to perform. So with that, we come to the end of the session, and we'll be happy to take any questions.
Yeah, so I have shared questions on the group, and I think we can start taking them up
Okay,
from
let
the
me
chat
just
window.
look at it.
Yeah. So one of the first questions that we got was how sensors are secured. So yeah, as rightly said, and we have also shared one methodology of framework for OWASP IoT Top 10. So mostly sensors, don't inherently don't have security. But what you can do is you can, if there are any mechanism of connecting the sensors to your either web or cloud solution or to your mobile apps or anything, there should be security in those communication, as well as how this sensors or devices end sensors or devices are getting authenticated, so there are no rogue sensors that can be easily latched onto your central system or your hub or whatever that you want it to connect to the ecosystem. Okay, so primarily you make sure that there are no default credentials, or if there are, the end users should immediately change once they have installed. And then the communication should be secure when they are communicating to the ecosystem or to the cloud solutions or to the mobile apps. Okay, hope that answers your question.
Another question that I see here in the group is, can you give suggestions regarding the security of IoT devices, the coding part, where we can find some codes for securing devices? So, see, if we are talking about any of the IoT device, there are multiple, security features that it should have, be it talking about from the hardware perspective, firmware perspective, or from the, boot level or the OS level perspective. Okay, we should have a security feature on all these layers. Okay, if it is a firmware level, we should have a proper code or proper firmware upgrade feature, that if it is upgrading over the air, we should have a proper update mechanism or secure update mechanism which is implemented as part of the IoT product. If we are talking about the the hardware level, we should not have JTAG, UART, or SPI ports open. They should be fused, and we should not be able to communicate or use that. The other thing is, if we are talking about from the from the coding side of it, there are multiple coding guidelines available, and even different organizations also have their own SOPs while they are designing the products. So that can also be followed as part of the IoT security um, for keeping IoT security in mind. There are other things like privacy and data storage that can be kept in the mind while you are designing the IoT devices. So these are some of the common security features that you can have as part of the IoT device or product.
Thank you, Neeraj. One of the another questions that I see is, do industry standards assessment on IoT or OT products? Is there any certification available? Similar question is, are there any ISO standards used for IoT devices? So I would like to combine these two questions. So what has happened is you do have you do have ISO 27001 kind of series for information security assessment and all, which can be used in general in the organizations. But primarily there is no specific standard as such. Certain controls or certain features you can take from NIST 853, which talks about securing some of those embedded devices and what needs to be there. You do have ISA 62443, that is Industrial Security Automation Standard, that talks about OT or SCADA related security. Also, it's a bunch of suite of standards, which also talks about certain products or certain integrators which they can use for their secure product lifecycle development, right? So a lot of security researchers or security assessments that many of the industry people do, they try to take inputs from ISA 62443. So you cannot certify as such the IoT device, but yeah, you can definitely take some of the control statements or map it to those control requirements present in those one of the suits of those standard that you can go back and you can do. And anyways, we talked about OAP's IoT top 10, right? So any findings of vulnerability or security researchers researching that you do, you can easily bucket it or club it so that the product team or the application development team can go and fix those issues as such. So yeah, so this is an evolving area, and we are expecting a lot of traction that is coming up, right? Okay.
By looking at the questions, I can see that there are multiple dimensions from where the questions are flowing in. So just to tell you, this was a very introductory session on the IoT security, and there are multiple aspects of it which can be covered. However, within this 1.5 hours, it is not possible to cover all the aspects of it, be it from the NFC, Zigbee, Z-Wave. You have DNP3. There are a number of protocols, or there are a number of dimensions we can talk about. Yeah, however, we restricted it to generic IoT security and BLE. Okay, to answer one of the questions regarding the BLE Mode 3. Okay, so we do agree that BLE Mode 3 has some of the good encryption standards in place. However, as far as our experience is concerned, we have not seen that enough in the market coming for most of the products. So we have very less experience with any product which has BLE Mode 3 implemented. What other questions we have?
So we have a question on how is there any tool to discover legacy assets or find firmware patch status? So as of now, the industry is not matured, or even the tool makers are not up to the speed to match, in this area. So there's no automated tools that you can easily deploy and have. But we have certain identity access management industry tools like SailPoint and then Savient, and there are a lot of enterprise related identity access management tools. Some of the examples that I said, and not necessarily they are the only one, right? which are coming up with features or modules that can include your not only mobile device management kind of a solution, but also your IoT sensors and devices that are there in the ecosystem. So you can authenticate, authorize, you can make sure you can track uh, what kind of assets are there. I'm not sure whether it still works for legacy assets of identification, but yeah, definitely you can go and add create custom groups in there, and then you can assign that group on certain rules, and then you can track who is accessing what kind of IoT devices and sensors, and then you can have a dashboard of reporting, bunch of reporting through them. So yeah, that's it.
Okay, any other questions we have?
So we have one question where manufacturing from if IoT devices are being used, do they fall under purview of security audits? So as we mentioned, this is something not entirely what we discussed, but yeah, as we said in the initial of the presentation, we have a lot of industries, not only manufacturing. We have a lot of smart power grids, electric grids, smart meters, and all, where Internet of Devices are being used, and where Internet devices are being used, and they are either connected to each other or to different machines or systems or to the internet. Yeah, definitely there would be some kind of security, in case that needs to be thought about by those industry people or by those people who are providing those products. So there is no mandate about security audits, but yeah, as we say, we don't need to wait till someone breaks open your door to install a lock or write controls, right? It's always better to be cautious and proactive in understanding what threats we have, as some of those basic level of threats we Neeraj also mentioned in the ecosystem, and then you can take it forward. So it all depends on the risk or appetite of the organization as well, where it is implemented. Okay, hope that answers your question.
I don't see any other question which we have not answered.
Yeah, Neeraj Chinkal, I have shared the questions on the group. If you feel that there are more questions which pertain to this session, so you may take them up.
Sure. There's one last question I think we'll take. Is there any platform to learn and understand consumer privacy and security issues while using IoT? Yeah, there is not some dedicated platform. We all are learning. It's a learning for us as well as to all of you. Day in, day out, we try to do assessments or try to understand what new devices or new ecosystems are being launched at an enterprise level, at a consumer market level, pertaining with security as well as privacy issues. So, what we also try to do is try to attend such webinar or conferences where certain topics are being discussed to understand if certain security researchers are coming up. There are well-known national and international conferences in terms of security researchers like Nalcon and then hardware and then Black Hat, DEFCON and all, where you would get to know if certain new vulnerabilities or zero days attack with respect to this industry is being used. And also you have a lot of, as I said, freeware small startups coming up with their IoT implementation stack, where you can virtually add devices and see how, let's say, temperature monitoring, or let's say you want water monitoring kind of a device to see how it functions. Maybe you can take a look at that. Also, there's an interesting thing which I forgot to add in the initial. There's a website called shodan.io. Maybe you can just click on it and look. You will see a lot of devices that are connected to internet open, like CCTVs in Russia or some plants or servers accessing open internet. So yeah, that's the level of threat that you can easily search for. Baby monitors, smart toys. Maybe your children are having some baby dolls or all which are connected to internet. They would also be listed down there and at remote part of the world. So it is, yeah, that's scary, and you can have a look at it.
Okay, I see one more question, two more questions basically. One is saying that what is the IoT ecosystem, and the second one is what products can we use to secure IoT products. So I'll club those both the questions in one answer itself. So IoT ecosystem we already spoke about. If you talk about any product for that matter, say we spoke about NVRs, which is a network video recorder. Okay, so a network video recorder might have different components attached to it. That network video recorder might have hardware. That network video recorder will have the software running over the web application. Displaying over the web application. It might have a mobile application also, which can be utilized to access the network video recorder. It can communicate to cloud also to store maybe some video recordings, and it is connected within an infrastructure which might have different network connections. So these all things, when they comprise together, they all become the ecosystem of any particular IoT product. So for this example, NVR, the network video recorder, is one particular IoT product, and all these components are the ecosystems. They are all the components are the ecosystem of this particular IoT product. And to talk about the second part of it, which is regarding the products. So I am skeptical if I talk about any particular product. Rather, I would say that we can utilize, secure mechanism of different protocols or different applications that we are building on top of any IoT product. So say, for example, if we are using cloud communication, we should use secure cloud communication or any secure APIs to communicate or to store any videos. If we are using any network infrastructure, we should understand that we should not use any public network to communicate anything which is sensitive. Or we should also utilize something which is not guessable, not weak, like the passwords or any of the keys. So these are some of the parameters or some of the ways we can look at. Any other question that we have? I hope that answers the question.
Yeah, I think you have successfully answered all the questions in the chat window.
Okay.
So yeah, thank you so much, Neeraj and Chinkul, for taking time out and facilitating this session today. I'm sure it was a very enriching session, and it was a very in-depth knowledge sharing session for everyone. So thanks a lot once again on behalf of SciSec.
Thank you. Thanks a lot to all the